welcome you all to this presentation. So here we are going to answer this question, and this is Mathematics, Paper 1, 2024. Here the question reads, calculate the retardation of the particle in the first 10 seconds. So here, the information has been given to calculate the retardation in the first 10 seconds, where the particle here has moved from 35 meters per second to 20 meters per second. Then what they want is what? A retardation. So remember, a retardation is same as what? Acceleration now in a negative what? Way. Okay. So here, the formula that we're going to use, it's I'll use this space for A. Okay. So for A, we are calculating a retardation here. Say A. So retardation, so it will be A is equal to final velocity minus, okay, initial velocity. So I'll use I, initial velocity, then over time taken, which should be in seconds. So here our initial, since it's starting from here, this side here is going to be our initial velocity I. Then where it is heading this side, this will be our final velocity, which is VF. Okay. And then the times the distance, we have already been given that in the first 10 seconds. So this is the time. Now we'll just replace what we have. A is equal to, now where there is F, VF here is final, replaced by 20 because it's coming from this side, coming at the constant of, at the velocity of 20 meters per second. So here it will be 20, it's our final, then minus 35, then over time here from here to there is what? 10. We have been given is 10 seconds. Then A is equal to this, and this will get its negative 15 here over 10. How many times can 10 go into 15? So A is equal to negative 1.5 meters per second squared. This is our retardation or deceleration. So now we once you ignore this negative, which means you are calculating acceleration, but here the answer is what? Negative 1.5. okay, negative 1.5. This is our answer. Now we'll move to the next one. Here the next one is speed of the particle when t is equal to 31. Okay, so here they want the speed of the particle when t is equal to 31. So here we have 27 here. We have 25 seconds. So where we can have this 31 is somewhere here. So it's just an approximate. So let's say it's somewhere here. Okay, here we have 31. So now since we have 31 here, what we'll do, we want the speed, so we can do like this. We can do like this. So this is the speed that they want is going this side. Okay, so they want the speed. Let me do this. Okay, so here we want speed here. Okay, I'll do something like this. Okay, so here this is where the V, that's the one, which is what? Velocity. Okay, so having this, first thing for us to find the velocity at this point. Okay, so here we have here the velocity here, it's 20 meters per second. So this side we can say it's 20. This is our velocity at this point. Then from here to there we can find the gradient. Remember, the gradient of the slope, it is what? It's equal at any point as long as it is in the same what? Line. So the gradient, when you pick the points from here to there, it will be equal from this point to this point. Okay, so now let's first find the gradient. How are we going to find the gradient here? We are going to find the retardation. Okay, we are going to find the retardation again for us to find the value of v. So calculating the retardation again, we use the same formula where we say a is equal to v final minus v initial, okay, over time taken, and this time should be in seconds. Okay, so here we have this here is our initial, since it's coming from, it's starting from this point up to this point here. So this one here, we are saying this is our initial. Okay, this is our initial. Since it's our initial, it's the one that we're going to put here. Then the final time velocity here in time axis here, we can say it is what? 0, because velocity only appears in this what? In the vertical line. In horizontal line, velocity is equal to what? To 0. So at this point, our final velocity will be what? 0. So we'll say a is equal to final here, it's 0 minus our initial there, it's 20 over time taken. So there is 40, and this side there is what? 25. So we can find the difference here. The difference is just subtract 25 from 40, which will give us a 15. So time is 15 seconds. Okay, then here we're going to have a negative 20 over 15. The negative 20 over 15, what will be the answer here? We find the number that can go in this. So 5 there, I see negative 4 over 5 there, I see 3. So this is the answer, meters per second squared. This is the retardation. Okay, now we are going to use this retardation to find the value or at what? This point, okay, which is the velocity that they want. So we are going to use the same formula that we have been given. So here, remember the time is what? It's at 31. So 31 is a distance from 0 up to this point. It's what? 31. Then here what we want to calculate is just from here up to this point. We know the gradient here. So we are going to subtract 25 from 31 to find the time interval at this what? Point. Okay, from 25 to 31. So once we subtract here, we find that the time interval is what? 6 seconds. So here the time that is passing is what? 6 seconds. Okay, so the one that we are going to use. So now let's use this formula, or we use once multiply this one, we are going to use this one, which is v is equal to u initial velocity minus a t. Okay, here it's plus, sorry, it's plus, not minus, at. This is the formula. This one and this one are one and the same thing. Okay, so we can use this one or this one, are going to get the same answer. So here our gradient or acceleration, we know it's negative 4 over 3. It's the one that here we will get this one and replace where there is what? A. Then time here is what? 6 seconds. Then initial velocity here is this one, 20. So from here up to there, we just want the distance now in this what? In a vertical what? In a vertical line. Okay, want to find the velocity. So what we will do here, we just replace v, we replace by v itself, it is v final, then is equal to our initial here u, it's what? this side, which is a 20. So here we'll replace by 20, then plus open bracket, our a here is c, negative 4 over 3. So here it will be negative 4 over 3. Okay, then our time here, which is a 6 times 6, like this. This is what we have. So having this, we can work out what is in the bracket. So this side we say it's 20, then this 3 there it's 1, 3 there it's 2. Then negative 4 times 2, we are going to have a negative what? 8. Then 20 take away 8. What will be the answer here? It's 12 meters per second. So this is what? The velocity. This is the velocity when time is 31 seconds. So this is the velocity when time is 31 seconds. So here our answer is what? 12. Okay, 12. Then we proceed. Average speed, the average speed of the particle for the whole journey. So here they want the average speed. So remember, for us to find the average speed here, first thing we need to find the distance. Okay, the distance of this diagram. Don't be limited in the way that you can answer. First thing, we can cover this part here. Okay, when we cover this part, which means we are going to have something like this, which is a trapezium. Okay, which looks like this. So this is a trapezium. So this one, as for me, when I do something like this, I'll name from here up to this point here where there is 40. So I'll do like this. Okay, I'll do like this here. I'll name this to be my B. From here up to this point, it will be my B. Then from here again up to this point where there is 25, it will be my A. Okay, it will be A. This point is going to be A. Then here up to there, which is height, it's going to be H. It's going to be H. Okay, it will be H here. This is H. So having this, which means the formula that I'm going to apply here to find the distance, it will be G is equal to half, open bracket, A plus B we close, plus, oh sorry, it's times H, which is the height, the formula of the trapezium, plus, okay, remember I've covered the other one. So here, as you can see, this part here, this one here, is just what? The half. Okay, this is half. I'm going to exclude this part. So once I exclude this part, which means I'll do something like this, I'll take away 20 from 35. So here I'm going to have what? I'll have a 15 here. Okay, I'll have a 15 this point. I'll have a 15 this side. Then from here up to there, it's what? It's a 10. So to find the distance here, I'll use half BH. Okay, half BH, where my H will be 10. Okay, then B will be 15. So I'll take this one here and add it here, which will be half BH. Okay, so this is what I'm going to use. So having this, I'll start replacing half, open bracket. So A here, my A, remember I said that my A here is this point from here up to there, which is 25. So I'll take a 25 here. So where there is A, I'll use 25. Okay, I'm going to use the 25. Here I'll say 25. plus, then B here, B is C from 0 here up to 40 this side. So there is B. So my B here is 40. Okay, my B is 40. So here I'll say 40. I close. Then height here, my h. Okay, my h at this point is what? Is C from 0 here up to this side, which is a 20. Okay, say 20 there. I'll say times by 20, then plus half times my B here is this small part. So here I said it's 15. Here it's 15. When you do 35 take away 20, you are going to have what? A 15. So there is a 15. This side here is 15 times my height here, h is from here up to there, which is 10. Okay, it's the one that I'm considering this part. From here up to there is what? It's 10. Okay, so here I'll say 10. So having this, it means we can work out this. This is multiplication. So there I can divide this into this. Is how many times? It's 10. Okay, there is 10. Then here we have I have 25 plus 40. It will give us what? It will give us 65 times 10, which is this one here, close bracket, plus there is 1, there is 5. Okay, then 5 times 15. 5 times 15, so 5 times 5 is 25. So I'll just say 5. Then I'll keep 2. This and this is 5 plus 2, 75. So I'll have a 75 here. Then once I multiply this and this, what am I going to get? This and this, I'll get a 650 plus 75. So what's the answer here? What's the answer? This and this, 6, this one times this, so 5 times this one will get 5. Then this one here is 7. 7 there, you get a 2 this side. Okay, you get a 2. Then this one here, you get 7 meters. So this is what? The distance. It's the distance. Now the question, they want us to find the average speed of the particle for the whole journey. So now for us to find this answer here, which will be the average speed for the whole journey, you just say S. Okay, let me use this part here. Okay, this had 3 marks, and we'll say speed is equal to distance over time taken. So here our distance is this one, which is 725 over time taken here. So we'll take this. This is the time taken here, which is 40. Okay, 40 is the time taken. It's the one that we are going to consider here. So we'll divide by what? 40. Okay, this is the one that we are going to use, 40. Now here this is paper 1. Okay, so it's paper 1. Since it's paper 1, you can reduce this. You can find the number that can go into this and this without giving any remainder. Is what? A 5. Okay, 5 can go into this and this one. Then so say 5 there is 8. Okay, 5 into 40, it's 8. Okay, it's going 8 times into 40. 8 times. Then 5 into 7 there, it's 1, remainder 2. Okay, so 2, I'll put it there. 5 into 22, it's 4. 4, then remainder 2 again, I'll put it there. Then 5 into 25 is 5. Okay, so this is the answer. When one side just it like this, so this will be the answer on top, because I know that 5 can go into this because of this 5 there. So I know that 5 can go into 7 one time, remainder 2 there is 4, again remainder 2 there is 5. So here is the answer. And then again we can reduce this. How many times can 8 go into 1? Into 1 it's 0. Then into 14, how many times it's C? 1 time. Okay, so 8 here it's C, 1. 8 there. Okay, so since this one will be a fraction, so we'll say it's C, it's 1. Okay, then remainder it's going there it's going to 14 1 time. Okay, remainder 6, so we'll get 6 and add it to 65 here. Then 8 into 65, so it's going into 64. How many times? 8 times, because 8 times 8 is 64. So it's going into 64 8 times. Remainder 1, remember this is 5, so here's the remainder, it's 1 over 8. Okay, so you can leave your answer like this, and then you say meters per seconds. This is what distance. If at all you can again simplify it further, like this one, we know that this one can go into this like this 18. Here there is a fraction, so it means there's supposed to be a point, this, so it's point there is 0, and then we can add a 0 this side. Okay, we add a 0, then 8 into 10, it's 1, remainder it's a 2, remainder 2, it's 1, remainder 2, again into 2, it can't go, and then you add a 0, so that it becomes 20. Then 8 into 20, it's 2. Okay, remainder 4 again, it's 2 into 16, remainder 4, then you also had the 0. 8 into 40, it's 5, then meters per second. This is the answer. So here I was just showing you on how, if at all you have time, you can also leave your answer at this stage. Okay, because this one is not going to give you the recurring figures. Okay, so you can answer this without using a calculator like this. Okay, then here you can also leave your answer at this stage. You'll be given a full mark. Thank you very much for following.